CBS television presents a special report on Sputnik 1, the Soviet space satellite. Douglas Edwards reporting.
Until 2 days ago, that sound had never been heard on this earth. Suddenly, it has become as much a part of 20th century life as the whir of your vacuum cleaner. It's a report from man's farthest frontier, the radio signal transmitted by the Soviet Sputnik, the first man-made satellite as it passed over New York earlier today. Right now, it's over Auckland, New Zealand. According to the latest Soviet announcement, the satellite is still maintaining its speed of 18,000 miles an hour, meeting no resistance 560 miles out in space. The Russians say it'll be joined by another very shortly, and there will be advance notice this time. What the Sputnik signal means, we still don't know. The Russians haven't said anything about that. Our own experts haven't found any coded information in it. The sound may be no more than a means of identification, a way to keep track of the beach ball-sized metal sphere as it hurtles around the world 16 times every day, a dozen times faster than any man has ever flown. The event itself, the sudden Russian advance to the far frontier ahead of every other country, that event is full of meanings, clearest of all to scientists whose work is the exploration of space. And one of the places where the progress of the satellite is being watched most closely is the Hayden Planetarium in New York. CBS News correspondent Richard C. Hottelet reports from there now.
Doug, we're in the great dome of the Hayden Planetarium in New York, and I have with me Dr. Kenneth Franklin, an astronomer on the planetarium staff. Dr. Franklin, can you tell us where the Sputnik is now and how it's moving?
Right now it's north of Auckland, New Zealand, and moving southeast. It will be, in 10 minutes, about 1,500 miles north of Little America, and in about 24 minutes it will be over Santiago, Chile, and in about 50 minutes from now it will be over Spain.
Well, it looks as though it'll be missing the United States on this trip.
That's quite correct, it will.
But it does come over here periodically, doesn't it?
It comes over here at least twice a day and maybe more.
Well, now, when are we going to be able to see it?
Well, it will be perhaps 10 days or 2 weeks from now. We can't see it now because it is over us during the daytime, and we cannot see it during the daytime because our sky is much too bright. We have to wait until our sky is dark, but the satellite is still illuminated by the sunlight. This is a very special condition.
Yeah. Well, now, I wonder, Dr. Franklin, if you could show us here in the dome of the planetarium how the Sputnik will look to people lucky enough to be able to watch it in twilight.
Well, it'll move very faintly, but I can demonstrate it to you. We have the lights out, please. It will apparently come from the northwest first, travel across the sky amongst the stars. They will be visible at this time, and travel off into the southeast, gradually fading as it goes.
Will it be visible to the naked eye?
Very slightly, if you happen to have good eyes and have a good seeing condition in the vicinity of your observation.
I understand that the beep signal changes occasionally. What's the meaning of that?
Well, it appears to have a rather high tone when it's coming toward us, and the tone changes to a lower tone as it goes away. This is the normal Doppler effect. You actually can experience this yourself if you're sitting on the roadside and a car comes by. It goes zzz as it goes by, you see, and this is a normal Doppler effect that you experience every day.
What do we know exactly about the Sputnik #1?
Well, the Russians have told us that it is a sphere about 23 inches in diameter, that it weighs about 184 pounds, that it is in an orbit which carries it about 560 miles above the surface of the Earth, that it travels around the Earth in about 1 minute and 36 seconds.
An hour and 36 minutes.
An hour and 36 minutes, yes, I beg your pardon.
What more can you deduce from the existence of this thing as to its makeup, its construction, and the rest?
Well, it has to be solid enough, of course, in order to be able to get up there to withstand the shock of the launching of it, so it has to be rather sturdy construction. It may well be made of magnesium alloy, which is a light, strong metal. We don't know exactly how thick the shell is, of course, but it has to be thick enough to withstand some of the rigors of the meteorites that might strike it.
Well, now, with all these hazards upstairs, how long is it likely to stay up there?
Well, that's a matter for estimate at the moment. We have to be able to tell something about the structure of the atmosphere up there. The Air Force Cambridge Research Center has a model of this atmosphere, a guess, which, when put into the numbers, the calculations show that it should last about 20 years. But perhaps the model is not correct. We'll just have to wait till it comes down to find out how long it's going to stay up.
How long will it go on broadcasting?
That's another mystery at the moment. The Russians have not told us what is in the satellite outside of radio equipment. What kind of batteries there are, we don't know. If it lasts for more than about 3 weeks, continually broadcasting, perhaps they're using solar batteries.
Why are we having all this trouble tracking it, that is, pinning it down precisely in space?
Well, for one thing is we cannot see it visually. And another thing is that the radio waves are coming to it, well, it's moving very rapidly, it's very weak, and the radio equipment that we have available was not designed to look for a Russian-type satellite. The frequencies are not the same as those which we had planned on for our satellite.
Well, now, wasn't all information going to be pooled in this geophysical year?
Well, that was the original plan.
Mm-hmm. And the Russians just didn't come through with their information?
They didn't come through with the information on this particular point at any rate.
Well, can't we track it by radio direction finding or by radar?
Such a thing is possible, but it's a rather technical thing. It may be that we have some very sensitive radar equipment which is capable of tracking it, but we don't know. This is a province of the military, not of the scientific part of the United States.
Well, Dr. Franklin, it occurs to me that if the United States, if the American scientists are not able to track this thing and report to the central sort of information or distribution agency of the International Geophysical Year, that the Russians are missing out on a lot of information they might otherwise get, very valuable information. Is this the case?
Yes, that's quite true. If we were able to track it for them, we could assist them in knowing what its orbit was. Now, unfortunately, they are having exactly the same problem we are. It's going over their territory in the daytime, too. So they can't...
Is that bad planning on their part?
Well, maybe this thing, you can't tell whether it was, maybe somebody sat on the button at the wrong time. I don't know.
But to get back to the sort of scientific void that the United States represents with no capacity to track it, would it be possible that the Russians have ships at sea or equipment in embassies and consulates around the world which would make them independent of our scientific observation?
Well, I rather doubt that, unless perhaps they have something top secret that we don't know anything about, of course, that we haven't contemplated. It takes a rather large amount of real estate to set up one of our mini-track systems, and they don't have that around embassies and ships at sea.
Getting back to this track, is it possible that it is transmitting a code, not just a beep signal for radio listening?
Yes, it's quite possible that it's transmitting a code, but we don't realize what the code is, of course. Mm-hmm. And I suppose if this is a code, it's a very fine one.
Well, how would it be possible to ascertain whether it's code and maybe to crack it?
Well, the beep signals apparently consist of short pulses lasting for a duration of a third of a second, a series of pulses during a third of a second. These pulses would have to be analyzed for any systematic changes with the position of the satellite in its orbit. In other words, with the conditions in which the satellite might find itself and being reporting back.
What would you say is the value of this satellite project to science?
Oh, it's of immense value. We can learn much about the structure of our upper atmosphere and the domain of this particular satellite just by its behavior up there. And also by its behavior, we might learn something about the shape of our Earth. We know that it's shaped something like a doorknob, and possibly it's perfectly round at the equator, but there are indications from time to time that the equator might not be absolutely circular. The motion of this satellite will tell us something about this.
Well, thank you very much, Dr. Kenneth Franklin, and now back to Douglas Edwards in Studio 42.
Thank you, Dick. Stay with us. We're coming back to you in a couple of moments. One meaning, very quickly read from the launching of the satellite, is an ominous one. This is that the Russians have licked some of the toughest problems of rocket propulsion, the basis of the so-called ultimate weapon, the long-range ballistic missile. The Russians have proved this months before we were ready to show the proof of our own rocket research, the launching of the first American satellite scheduled for next spring. The satellite, American or Russian, has no power of its own. Like the explosive warhead of a missile, it's just the cargo of a rocket, or rather a series of rockets arranged in tandem. The initial thrust to get it into the air comes from the lowest and biggest of the rockets in the tandem. When the American satellite is launched, the takeoff power will come from a rocket like this one shown in a recent test. The powerful thrust of the Aerobee sends the whole assembly up through the dense stratosphere, a layer of heavy air 50 miles thick surrounding the Earth. The first rocket is then dropped, its fuel exhausted. A second rocket ignites and takes over. Altitude 140 miles, satellite being stripped for action. It's that round ball in the nose. Altitude better than 250 miles, and the second rocket burns out, but its momentum carries the whole assembly forward. Second rocket spent, the third and last one takes over, the final thrust that carries the satellite into its chosen orbit. Then all the rocket power gone, but tremendous force has been built up, and the satellite is pushed off on its own at a speed of 18,000 miles an hour. A fixed course circling the Earth beyond the reach of the Earth's gravitational pull. Hundreds of miles in space, the satellite's instruments start collecting data, sending it back in the form of radio signals. A pilotless spaceship, man's advanced scout in outer space. More on rocketry from Dick Hottelet at the planetarium.
Doug, we're here outside the dome of the Hayden Planetarium with Dr. Franklin Branley, the associate astronomer of the planetarium, and also a full-scale model, a mock-up of the Viking rocket. This Viking rocket was the first phase, the first stage in the development of the Vanguard project, which is the American project for hoisting the satellite, the American satellite, into outer space. Dr. Branley, I wonder if you could walk along this rocket model with us and tell us just how a machine like this can get a scientific satellite out of the clutches of gravity.
Well, actually, Mr. Hottelet, this particular rocket cannot do that because this is only the first stage of rocket Vanguard. This particular rocket is only 45 feet long. I say only because when we compare that to the 72 feet of Vanguard, it is really not very much of a rocket.
Yeah.
However, we learned a great deal about the problems of getting a rocket started and moving into space by experimenting with these Vikings, rather.
Yeah.
That led up to Vanguard.
Are these chambers all propulsion chambers? They carry fuel, or what is the function
By
here?
far, the larger percentage of this rocket is made up of fuel and oxidizing chambers.
Mm-hmm.
You see, it takes many, many tons of fuel to get a few pounds of payload into outer space.
Yeah. Well, I wonder if we can move over now to the smaller model of the Vanguard rocket, the rocket now being constructed by the Martin Company to get our Earth satellite out into space. Could you explain something about this?
This is a 12-to-1 model, Mr. Hottelet. It's 12 feet high. The actual rocket is 72 feet high.
Mm-hmm.
And there are 3 stages here. The first stage burns out in about 40 seconds when the rocket is going 4,000 miles an hour.
Mm-hmm.
And after a few more moments of time, the second stage burns out. And then the third stage takes over, which will accelerate our satellite to 18,000 miles an hour.
Well, now, I am told that our satellite will weigh about 21 pounds, and the Soviet satellite weighs 184. This is, of course, a tremendous advance over ours. Does this mean that the Russians have developed some novel method of rocket propulsion or made some breakthrough in this science?
Well, it would seem so, because our total rocket weight for Vanguard will be 22,000 pounds. That's to get a 21-pound satellite into orbit. Here we have a 184-pound satellite, and so one could assume that the rocket required to get the satellite into orbit must have weighed in excess of 100,000 pounds. This is rather amazing. It is a breakthrough. There's no question about it.
Well, let us get down to satellites in general. What kind of information do you want from this satellite? What is it set up to do?
There are hundreds of problems that we'd like to solve with these satellites. Practically every scientist across the United States would like to have his pet problem pursued. No doubt early satellites will investigate temperature of outer space. They will use thermistors in order to do this. These thermistors are very delicate devices which will register very slight changes in temperature. Then also we will have weathermen will put photoelectric cells into some of the satellites, and these will give us some idea of cloud cover all over the Earth in a very short length of time. And then we shall also have the atomic scientists investigating the nature of cosmic particles.
Well, now, the satellite collects all this information. How does it get it back to the ground?
In each satellite, that is, in each instrument-carrying satellite, there will be a mercury battery which will supply power for a miniature radio transmitter. And also, in each satellite, there will be a magnetic recording drum. Information is changed to an electrical signal, and this signal is recorded on the magnetic drum, and when the satellite passes over a receiving station, the miniature radio is turned on and reads out to Earth all of the information that has been recorded on the magnetic device.
What kind of radio does the Soviet satellite have?
I
Does it have an atomic batteried radio, would you say?
We can't say. Some of us have felt that maybe because it weighs so much, that a large part of the weight is made up of a battery pack. The Russian satellite is transmitting consistently, which means that a great deal of electricity is required.
Well, this is a tremendous operation. Would you say that this is a breakthrough, a basic breakthrough for science?
Unquestionably, and I think the Russians deserve a great amount of credit for achieving this seemingly insurmountable problem of putting such a heavy satellite into orbit.
Well, does this mean that space travel is now a feasibility? Is this the beginning of launching men into space, of setting up space platforms?
This seems unquestionable, and we want to do that because we want to set up telescopes in outer space, for example. And we want to have weather stations established there so that we can see the weather pattern over the entire nation at once, and so have warning of storms, tornadoes, hurricanes, and other disasters of a meteorological nature.
These are enormous peacetime uses, and we can only sit back and look up and hope that they work out. Thank you very much, Dr. Franklin Branley. Now back to Doug Edwards in Studio 42.
Knowledge about outer space or any other part of man's environment is not a national thing, as the scientists keep warning us. Every new device starts as a collection of ideas, and ideas can't be staked out like national boundaries. But in a time when international rivalry is the world's prevailing mood, science, like everything else, gets thrown into the scales where one country is measured against another. The fact staring Washington in the face today is that the pointer has swung sharply to the Russian side. Sputnik 1 is in the air. The space satellite, which the United States has been planning to launch for several years now, won't be ready until next spring. The question now is, how does Sputnik compare with our own satellite? And how much danger might there be in the Russians' head start? Here's the way that question looks in Washington. Howard K. Smith reporting.
Well, here in the Washington studio is Dr. Homer Newell, of the Science Program Coordinator for Project Vanguard. And we'll ask Dr. Newell just exactly that question. What are the differences between the Russian satellite now buzzing around over us and our own projected one?
Well, as you know, our own projected satellite is designed to study different problems of science during IGY. The satellite, the Russian satellite, which is now in orbit, as Blagorovov has said, is a very simple version, a precursor probably of others to come. We are planning to build 4 different models of satellites that can be launched during IGY. The first one will be designed to measure solar radiation and micrometeorites, small particles that may be out in space. The second one will be designed to study cosmic rays. A third one of our models will be designed to study the Earth's magnetic field and perhaps to give us some information about current rings way out beyond the Earth's atmosphere. The third one will be a meteorological satellite.
Mm-hmm. Well, how about the physical differences? Theirs is much bigger than the one that we plan, is it not?
This is correct, apparently.
Is that easier to do or harder to do than the kind we're planning to?
Well, in order to launch it, it's much more difficult. But in order to instrument it, I would say it's much easier. In the case of our satellite, we have had to miniaturize everything, and this has given the scientists and engineers a terrific problem.
Well, Dr. Newell, what about the vital question that everybody is thinking about? Why and how did the Russians beat us to the draw?
Well, in answer to that, I'd like to say a few introductory words first. When we began our program, the planners and the engineers and the scientists drew up a schedule for themselves which consisted of a number of logical engineering steps to lead to the final objective. Now, this schedule placed them in a race with time because they had to get the satellite up during IGY. And naturally, we can assume that the Soviets did the same thing, and they were in a race with time also with the same deadline. It therefore seems quite reasonable that one or the other would get a satellite up first. It would, in fact, be a very remarkable coincidence if both of them went up on the same day at the same time.
Was it a surprise to you that they got there first?
Well, it was something of a surprise, and naturally, since this generates a certain amount of scientific rivalry, something of a disappointment to us. But this does not lessen our admiration of what the Soviets have done.
Well, thank you very much, Dr. Newell. Back now to Douglas Edwards in New York.
For the Soviet Union, the satellite is more than a scientific triumph. It's an opportunity that may be without precedent in the field of propaganda. Moscow is on stage, holding the world's attention, has control over the latest information on a subject of huge importance and certainly universal curiosity. And it can wring almost any kind of emotion from this dramatic situation. Gratitude, hope, respect, fear. Moscow has not been passing up its opportunities, as CBS News correspondent Dan Shore observes in a recorded report from Moscow.
The man in charge of Russia's Earth satellite program says today that Soviet scientists are now working on the problem of launching a satellite that will return to the Earth undamaged. Professor Yevgeny Fyodorov says in an interview in Pravda that solving this problem is important not only theoretically but practically. Indicates this would produce much more data than can be transmitted from the present satellite, which is doomed to burn up when it descends towards the Earth. How close Russian scientists are to solving this problem and how they're going about it, Dr. Fyodorov doesn't say. In fact, although the main Soviet papers today devote more than half their space to the satellite, with front-page banner headlines such as rarely seen in this country, there are precious few scientific details being divulged. The headlines are about glorious victory of Soviet science, or, as the Communist Youth paper says in a banner, the first in the world is ours. The stress is on exploiting the satellite as a political and propaganda triumph. A Pravda editorial says, no social system is so interested in developing science as the socialist system. Our scientists have achieved outstanding results with the effective support of the Communist Party and Soviet government. The United States is depicted as being in a state of admiration, confusion, and surprise. And Russians are told that the American myth of a Soviet lag in science has been exploded. American officials who discounted the Soviet feat described as talking utter nonsense, and so-called American military and monopolistic circles said to be in a foolish situation.
Dan Shore reporting to us from Moscow. Proud words from the government whose scientists shot this first scientific arrow far out into space. We'll have the reactions of other governments in Europe, and for those reactions, we're placing a call to Alexander Kendrick, the CBS News correspondent in London. Alex, do you hear me?
Yes, I hear you, Doug.
Just what do the Europeans think of all this?
Aside from the first reaction of surprise, of course, Doug, there's a feeling here of disturbance that for the second time now, very quickly, the Russians have been able to triumph over American technique. And of course, British scientists are confident that the United States will eventually overtake and surpass the Russians, but overtake and surpass are Russian slogans, so the usual roles have been reversed. And therefore, there's a lot of feeling here tonight that political theory about free science and a free democracy should be reassessed in the light of the substitute that the Russians seem to have found, the substitute of organizing and concentrating their scientific brains, backing them to the hilt by unified national resources, and without any conflicting interest to interfere with the development of science.
Well, Alex, apart from surprise, what would you say has been the strongest reaction among the Europeans? Fear, simple curiosity, or what?
Now, I think on the political side that this now accentuates the lesson that Europe learned from the shooting of the ICBM that the Russians did a few weeks ago. And Britain, as a marginal nuclear power, and the other countries of Europe as nuclear have-nots, are impressed more than ever by the fact that Europe now seems to be the odd man out between two nuclear giants. Just a few days ago, the Labour Party, at its annual Congress, surprisingly reversed its normal position and came out against a unilateral renunciation of the H-bomb. And apparently now, any hope that the Russians might have that the British will go along as a sort of neutralist, renouncing power has been shattered by the Labour Party stand, so that whatever government comes into power in Britain, I think Britain is more than ever determined now to stay in this race and make it more than a two-man race.
Thank you very much, Alex Kendrick, reporting from London. For scientists and military technicians, both in the East and West, some important questions about the world of outer space are now beginning to be answered. Some of the blanks in our information about the Soviet Union are also being filled in. These answers are not all we expected, and some of them are not very reassuring. At the same time, some of our basic ideas and practices in the age of international competition are being called sharply into question. Here again is a report by Howard Smith on some of these current vibrations in Washington.
Well, there's very profound concern here, Doug, about world opinion. The dominant conflict of our time, the Cold War, is at present, as everyone knows, in a state of balance between Russia and the West, and in between are those people who are called uncommitted, who may determine who wins, the peoples of Asia, the Near East, and Africa. Russia already enjoys one great attraction for these important peoples, and their ambition is to pull themselves up from primitive agrarian countries to become modern industrial nations. They tend to admire Russia as a nation which was once as backward as they, but which did pull herself up. And now that backward Russia has beaten the West's most advanced nation into the fringes of outer space, their admiration for Russia can be expected to increase. And there may be another consequence. Russia has in recent months been threatening nations who grant bases to America. Those threats have not been taken very seriously, but now the world knows that it took a far more powerful projectile than America possesses to push that satellite into its orbit in space. In view of that, Russia's threats may be more effective from now on. Probably no one here in the nation's capital would disagree with one thing that Senator Wiley said. We had better get on our toes. Now back to Douglas Edwards.
Here in New York, the latest word off the news wires indicates that there has still been no confirmed actual sighting of the Soviet space satellite. Astronomers around the world, however, of course, lining up their sights and expect to be tracking it soon. Meanwhile, according to the latest Russian reports, Sputnik 1 holds its course some 560 miles out in space, and as we've heard in these reports from both at home and abroad this afternoon, the course of United States policies in the competition with Russia has been severely shaken. This is Douglas Edwards. Good evening.
CBS television has presented this special report on Sputnik 1, the Soviet space satellite with the cooperation of the American Museum, Hayden Planetarium. This program was produced under the supervision and control of CBS News.